Hey everybody. So in this video I want to go over the kind of the process that I utilized to be able to create essentially any algorithm that I want. And first of all, I want to go into kind of my logic for why it works, and then I want to go into kind of like how it works, and then I want to finally go into kind of like how I back into it. So starting off with why it works. So kind of the very first place that I start is there's kind of a seminal paper currently with regards towards the mathematical capabilities of ChatGPT and LLM models, and the paper happens to be called The Mathematical Capabilities of ChatGPT, which makes it really straightforward. And so we could dissect and go through this whole entire 37-page paper, but the bottom line that I get out of this and what is meaningful to me personally out of this paper as a non-mathematician and like someone that is not deep into mathematics and mathematic theory itself, the bottom line to me is that ChatGPT gets me an undergrad or better when it comes to mathematical concepts and being able to build mathematical equations. And so like someone that has an undergraduate degree, like if I wanted to utilize ChatGPT to flat out pass every single math course that I would need on an undergrad level, I could get that from ChatGPT. And then so for a mathematician, maybe like that's not fine, right? Like you want a PhD level or a master's level, but I don't care. I just like undergrad math. That's perfect. Let's go. I can utilize that. I'm not. I don't need the actual equations to be the most advanced ever. I just need the model to be able to do the equations and to be able to function the logic to understand to build these equations, and it can clearly do that. So we can first off establish that from a mathematical level these concepts aren't it's not rocket science, it's not like brain surgery, it's not neurosurgery, like neuroscience, like we're like it's taking logical, like what I'm doing with it is taking logical concepts and logical ideas, and then formulating those into mathematical equations. And then so that's I've taken undergraduate logic courses. Like so, when I how I got through the math course that I had to take for undergraduate was I took logic, and then in undergrad, and then so if ChatGPT can handle undergrad logic, that's all I needed to do. Like, and it can do those processes for me. Boom, that's what I want, and that's what I need, and that's what it does. So fantastic on that end. So kind of now that we've established how it can work, how do I utilize it within this? And then so I've created this article here and then this algorithm that I created, and I'll link both the GitHub and the links to this article as well. But the article is for the algorithm, and I call it OCARD. And it's OCARD very specifically because it's based off of Orson Scott Card. Like so, I start off, and then this algorithm is very specifically designed to create the best science fiction writer possible. And that's my goal when I start off, and then that's why it's called O-Card and why it's based off of Orson Scott Card. Because to me, I start off with a brainstorming session and logically defining what the perfect science fiction writer is. And then so to me, the perfect science fiction writer is a person that has a strong protagonist. They have complex characters in their stories. They can build rich worlds, and then they have thought-provoking themes. And then so who encapsulates that the most for me, it's Orson Scott Card, and then so that's why it's called O Card. And then so okay, so now that I have kind of these are the elements and I can define them, right? Strong protagonist, complex characters, rich world building, and thought-provoking themes. I've got these general concepts. Now I want to define them into an equation. And then so I essentially run this through the AI models, and then I get Card's equation. And then so in this instance, it's a Card's equation is essentially strong protagonists plus complex characters plus rich world building plus thought-provoking themes times originality plus sense of humor equals essentially Card's equation, or the Card's science fiction algorithm. And then so real simplistically, it's essentially just taking that logic and then converting it to a mathematical equation. And then so here's the other piece that got me onto this, and when I realized is, so we can utilize AI models. There was a recent breakthrough where they were able to utilize an AI model to translate a 5,000-year-old extinct language into English, a language that doesn't exist, hasn't been spoken in 5,000 years, just easily able to translate it into English, right? Because it's under, like, at the end of the day, when we're talking about natural language processing algorithms, that's what they do, right? They're processing the essence of language and the patterns of language and pulling that out. And then so their understanding of language and math are both kind of along those same lines. They understand the patterns and then the patterns of that very well, which is why in this instance where I want this model to be equating logical equations, it works out beautifully in that instance, because it's I'm looking for the underlying pattern of this, right? The underlying pattern of what a strong protagonist is, the underlying pattern of what a complex character is, and then the underlying pattern of translating that from English to math, and then, like, all of those things are very easy for an AI model to do. They fall under the classification of categorization, which is what, like, a typical AI model loves to do, right? It wants to classify everything, so it has no problems with anything that I'm throwing it on this level. And then so the next step with that is then, okay, now we've got our equation. Let's convert that into, like, actual code and actual useful code. So if we were to code out this algorithm, what would it look like? And then it would essentially look something like this code here. And then what we can see is that from just, like, doing this exercise, we can see that our larger algorithm, our card science fiction algorithm, is essentially, at its core, it's made up of about, let's call it, 15, more like 10 underlying algorithms. So there's about 10 algorithms that we need, and we will need to build out these algorithms in order to get the end result of the card science fiction algorithm. And then so the end result of the card science fiction algorithm will be this combination of these other algorithms that we build out. And then so we can see that the very first one here is the strong protagonist algorithm. And then so if we want to essentially take this a step further, then we have to define the class within Python. That's how we would do this as the next step. And then so we would define the class of a protagonist. And then defining a class of a protagonist is what makes a protagonist. And then so in this instance, what makes a strong protagonist. And then so if we're looking at this code, just dissecting it for you, what makes a strong protagonist in this instance is the fitness of the protagonist, as well as the general population size of the environment where the protagonist interacts in. And then so fitness in this instance is defined by intelligence, resourcefulness, strength, and motivation. And then so essentially what this equation does, and this is just clipping some of the equation, but it essentially, all of those attributes, the intelligence, resourcefulness, strength, and motivation, each get assigned an individual score. And then those individual scores then are what are combined into the model, and then that's what actually is calculating on. So you can actually, by utilizing this algorithm and then by feeding it data on a protagonist, you can get the model to produce an output that this is a strong protagonist or this is a weak protagonist based off of the actual inputs and the numbers that you put in here. So of course there's the element then of getting that right, like, and all of AI comes down to that. Like, at the end of the day, like, this is where conceptually this is all very easy, but then you have to, like, actually get, like, the real world numbers that you need to plug in here, right? And then that's where it gets more complicated. But showing theoretically that this is just very easy to do on a theoretical level, and how easy this is to set up. And then so once we have all of that, and then if we went through and we did this same exercise for everything, not just protagonist, but for the character algorithm, the world building algorithm, the thought-provoking theme algorithm, etc., our end result would be the card science fiction algorithm. We would just combine all of those algorithms, and then if we want, we would run a story through, and then the story would be dissected and then picked apart based off of all the parameters in our algorithm, and then the end result is the model would tell you if the story is good or not, what can be improved with it, how exactly to improve it, where exactly to improve it, etc. All based off of this mathematical algorithm that we build out. And then just very simply starting out with just the very basic concept, the most important concept that we need to establish in order to create all of this is what makes a good science fiction writer, and then that's it. And then from there we get all the rest. So that's kind of the explanation of how this works. And then so the final note that I want to touch on in this video specifically is how did I back into this? And then so to me it's I backed into this in kind of like a very straightforward way, but like I include this because I think that the way that I backed into this is interesting because it's how I was able to piece all of this together essentially. And then so for me, I've always been like my like kind of like hobby areas of focus have always been like philosophy and science. Like I like both aspects of them, and then science I like broad science like quantum physics, out space, like less biology. But so just kind of in that realm in those realms, and then so. Within the like philosophy aspect, one of my favorite philosophers is Gilles Deleuze, and then so Gilles Deleuze and Felix Guattari, and then so within that, Deleuze and Guattari, they came up with a couple of theories that are like I think are very big to me, which are one is lines of flight, and the other one is the rhizome, and then so lines of flight are essentially a way of thinking outside of logic, right? That's the like essential framing that I can give to lines of flight. And there, I mean, there's PhD students that like don't ask and understand the question of what lines of flight are. So my one sentence explanation is not going to do anything any justice on this topic, but that's the simplest way that I can boil it down to you. And then so I started off there, right? And then I wanted to essentially like it seems to me that there's a good correlation between and an easy correlation between like being able to create an algorithm based off of lines of flight and kind of break that into a mathematical equation. That's where I started in my head, and then building an equation off of that. And so I was like, hey, let me try that out. And so I go through, and then sure enough, like it's easy enough to build a very complex but also simplistic mathematical algorithmic equation based off of lines of flight. And this is the simple and kind of complex equation at the same time. But so, and then this is kind of the like the deeper explanation into like lines of flight and how this particular algorithm works. And then so the next thing that this strikes my curiosity, I was like, wow, this works really well, right? And then so the next philosophical concept that Deleuze and Guattari explored is so they start with lines of flight, and then their kind of like end result of their journey with lines of flight is they create something and they call it the rhizome. And the rhizome has philosophical significance, and then recently it has like more and more prominence and significance in computer science and psychology. There's a few different aspects of like education that are adopting the rhizome as like an important concept in theory, and it's always been to me from a philosophical level like extremely interesting concept. And then so the rhizome again, it's like describing it in one sentence is not doing it enough justice on any level, but that's what I have in this to work with in this video. So the one sentence definition of a rhizome is a shapeless shape that cannot be, it can essentially be an indefinite number of things, and it can be infinite structures. And the structure and the shape of the rhizome and changing the structure and the shape of the rhizome has significant consequences. And then so that's where the significance of the rhizome comes into various other fields like neural networks, other and other areas. And then so to me, and so the biggest aspect of the rhizome in particular is the fact that it's outside of the bounds of logic, right? So it's like the opposite of linear and logistic regression. Like, it's as far away from those concepts as you can get. And then so because it's not based off of prediction, and then so it's like a completely brand new algorithmic type that exists. And then so I wanted to essentially like how exactly would and like what would be the shape of a rhizome for an LLM model. And then so essentially to me the shape of a rhizome for an LLM model would be, first it would take in the arguments from lines of flight and from the mathematical equation of lines of flight. And then so what the lines of flight mathematical equation, how it would translate to within a real world LLM model is you would take the input, and then from the input it would travel in random patterns to neurons until to the various neurons within the neural network until essentially parameters within the neural network until a terminator condition was met within that, and then it would essentially execute there. And then so that's what the lines of flight algorithm does. And then so the rhizome algorithm gives shape to that, and then says, okay, so I want you to not just follow randomness in the pattern, but then you're also going to adjust the weights as you go through this process, and then also you're going to start on the edges of the network and then kind of work your way inwards. So you're still going to pick something point at random, but it's our goal is essentially to tune the outer weights and then tune until we get the essentially what is established by the algorithm as the perfect tuning in this instance, and then that's when it executes and then stops. And then so in that instance, we're essentially giving it a non-logical output and an output that has no actual beginning or end, and then that's what the rhizome is, and then that's what lines of flight are. And then so we're telling the model with this algorithm, we want you to take this concept which doesn't have a beginning and end, which is we want you to tune yourself perfectly based off of this data, and then here's a framework that you can follow, and a mathematical framework that you can follow to actually give it a beginning and end, and then here's the beginning and the end. And then that's really all it is. So it's, here's the shapeless shape, here's a shape for the shapeless shape, here's how to follow the instructions to get your shape within the shapeless shape. So it's like a combination of like that philosophical thought and then mathematical thought, and then that fusion, and then so so that's where I got to with this. And then I was like, if I can create this and this works, which is like the opposite of logic and linear progression and logistical regression, then like I can do anything with this. And then so that's kind of just like where the next thing went. And then as I explored more, I was like, I was like, this is right. I can take any logical process whatsoever, and then I can code it into like an actual algorithm, from Asimov's 3 laws to what we went over with Orson Scott Card to I have an algorithm for the algorithmic customer lifetime value for marketing. If you want to calculate the CLV value of a customer utilizing the customer journey, like the typical customer journey, awareness, etc., like all of that, like the whole marketing aspect. Here's an algorithm that you can utilize based off of that, that will essentially give you outputs based off of that, and then it's all here. And so kind of just iterating and showing like how easy it is once you understand these concepts. And then I understand that these concepts probably aren't simplistic in general overall up front, but like to me they're like pretty simplistic concepts. Like once you understand and you start grasping all of this, and it's interesting, and then so being able to like create and generalize any and generate any algorithm that you want kind of feels like a superpower. I guess it's kind of like the bottom line where I'll end this video here. So if you like this content, please like and subscribe. Thank you very much.